design and quick layout. And that's my quick layout. It's my favorite one. And then once it gets in the chart body, I think all this stuff. Yeah, also, I'll show this again real quick. All these options, we got so many cool things. It's so nice.
Gary! I was just looking for the sports channel, Gary.
Hey everyone, how are we doing? I saw Cameron in the chat. I was loading the chat and then I clicked off of it. I did what Rick said and started the project early and turned it in. Wow, Cameron. I should go take a look at that top chat right there. I feel like there's no delay. Working with my TV. Good morning, William, right there. We got to get Mewbot awake. SpongeBob's over there watching some YouTube, some Statswo on UTK. We got Mewbot awake in the chat here. There we go. I need to set my volume so I can work with them over here on the music. It was actually fun. Nice to hear. Well, what should we do today? What is today going to be? You name it, we do it. Are people wondering about chapter 15, the project? What do we want to do? What shall we do? Let's start out with some points. You're here. Speaking of the project, can we do what I emailed you about? Yeah, William, which one thing is it again? Remind me. We got my emails over to the side. William, what's up? Log into my Pearson. It was about the, I think I remember now. I'll log in. It's about the tests? I think it's about the tests, right? About doing like a hypothesis test on the proportions. Look at the project and like put that first part of the video right here. You name it, we do it. I think that's what it was. Yeah, let's go look at that. In the video description. Thank you everyone who comes here and you make my day awesome. And I mean that because like, I've had office hours where no one shows up and it's like, no, I'm just like talking to myself and that's no fun. I'm just like, well, what should we do? I ran the test and did the equations on that. Was that what we were supposed to do? Yeah, I'll take a look right here. Let's go pull up the project. And so I'm pulling up the project as we speak. Basically, you just do what the project says, and then you look at the rubric, and then you make sure you did everything the rubric asked you to do. Ooh, a good project. There's a few projects turned in, but people are doing good work for who's ever turning in. Soundbars. Reddit wants to talk to me. Okay, let's go right here, instruction file. Pulling up the instructions. Okay. Got the instruction file loaded up. And so we'll put project in here. 433, stat 201, project proportion tests. Now let's go do it. Here we go. So we're jumping down to the proportions test right here, which is going to be in this section right here, the one sample Z. Actually, let me zoom in more. That's pretty darn good. So you have to pick a two-level categorical variable. Can anyone tell me what a two-level categorical variable is? What does it mean by two levels? You should understand that kind of lingo when we say something has two levels. So everyone should be picking a two-level categorical variable. One of the levels should be identified as a success level. What does this mean when something has two levels? I mean, a lot of things can be thought of as blank, blank, or you can have answers like yes, no, dog, cat, Sunday, not Sunday, whatever it is, there's two answers. There's only two answers. That's what two levels means, and it's categorical. Create a bar chart and frequency table. That's by analyze distribution. Make sure your bar chart is in horizontal. The bars have values labeled over them, so make sure to do that. I don't always do that on my videos, but make sure I do that. The frequency table should include the counts and the proportions for each of the totals. Mac users, make sure dark mode is not on. It's annoying, you have to go to your settings. We have a video on how to do it. Include a screenshot of the visualization, provide a short descriptive write-up of the variables. So just talk about what you see in the graphic. Next, create a confidence interval. Choose any percent, 90, 95, 99. Include the separate screenshot. Oh, you have to choose other than these. Sorry about that. You have to go to the other under the menu for that. So when you go to the red arrow, you'll drop down and go to other. I do have videos walking through this. I'm going to put the visualization in the chat. I think it's visuals or visuals. It's one of those commands right there. We'll bring up the visualization videos, and you'll see one on how to make bar charts. I'm pinning the message right there, so go check out that link in the chat if you're watching this now. And you want to see the step-by-step on how to do this, because I'm kind of just talking about what you need, not quite doing it. Name and describe the three conditions for confidence intervals for this variable type. So the first two conditions are what? Help me out with those first two conditions that we always know. For the remainder of the semester, the first two conditions will be this with confidence intervals and tests. So the first two conditions, random and then 10%. Mewbot loving that randomness right there, meaning we randomly select the observations, which you did to start this project. At the start of the project, I think you're taking a random sample. You are taking a random sample, 400 plus the last two of your UTID. So make sure you take a random sample in your project so you do have a random sample. The next condition will be 10%, which means you have 10%, less than 10%. Good to see you here, Michael. Feel free to ask some questions. You have less than 10% of the total population, which if this is UT students or something, you have less than 10% if you have 400 UT students, 450, whatever. 400 donors, 400 people who are measured for diabetes is less than the total population of, less than 10% of the total population. So you should be good on the 10%. The last condition right here, we have to what before we go to that last condition? What do we do before we say the last condition every time? So this is our step-by-step remembering how to do it. We do random, we do 10%, and then we what? We pause. Cameron knows the pause right there. Now this is categorical, which means the condition is what, which it kind of is alluded to here. So it even says you need to figure out which one is a success. So the last condition, great job with all those pauses. Good to hear, Lakin. So we've alluded to the idea of there being a success, so it's the success failure condition, which when you do this condition, you will actually use P naught. Well, no, that's if you do the test. We're doing a confidence roll, so you can use P hat. We don't know what P is, so we can't use NP, NQ to do NP greater than or equal to 10, NQ greater than or equal to 10, and no one should take off if you do greater than 10 or greater than or equal to 10. It's 10 is big enough, basically. Not large enough, but 10 is enough. That's a different condition. And so this is a different thing down here where we are going to use, so this goes right to the question that was asked from William. Next, use the 0.5 as the hypothesized value of P naught. So as the value your company believes to be the true proportion. So the null hypothesis, when we write it out, I'll put up my 2 hours later. What would the null hypothesis be where P naught is equal to 0.5? What would the null hypothesis be where P is equal to P naught and P naught is 0.5? We're going to show it here in a second. So what would the null hypothesis be? It's good practice if you don't have it right now. The null hypothesis, what would it be? How would it be written out? It'd be the null states, that's how that reads, the null states, you gotta make a full O right there, the null states. So that says the null states, and then what do we write after this? This is good practice if you're here right now, or if you're just seeing this later. How would we write the null? Close, Jake, I'm throwing you 10,000 points. That's what a lot of people do. That's a very common error. We're making Jake a mod right here. Jake, good work, worth some points, making you a mod, and a lot of people forget to put the P equals 0.5 right there, and that's because 0.5 is P naught, so the value of P naught is 0.5, so technically if you write this out in its basic format, it would always be P equals P naught, that the true proportion is equal to what we hypothesize it to be. But P naught is 0.5, so we substitute in the value of 0.5. And the alternative hypothesis I think that we're testing, I'll double check here in a moment, but that's why I usually ask right there, because a lot of people forget to put the P at the start of it, because think about what this would say without the P there. What would this say for the null? Like if you read it as a sentence, how does that read? What does this say without the P there? Just try reading this as a sentence, and if you get to the test, read it as a sentence to see if it makes sense. Like, what does that say as a sentence? So you have to read this that says the null states. So what does that read as a sentence without it? The null equals 0.5, which I guess kind of makes sense, but then what is it? And great job, Abigail, right there. We have to say the null states that the true proportion is equal to 0.5. Does that make sense? So the null states that the true proportion, so I'll underline it as I read it, the null states that the true proportion is equal to 0.5. The alternative hypothesis that we're testing is that the true proportion is not equal to 0.5. So the more you can read it as a sentence, that's when you get to like another one which we could test, which maybe we'll have a different hypothesized value. What does this read right here? Maybe I'm testing age of college students at UT. How would this one read? I'm testing age of college students at UT. How would this read? This is age of college students at UT. Oh, no worries. Well, we threw some extra points here. We'll throw you those 10,000 again for everybody. There you go. We'll throw those over there. Jacob, no worries. So how does this one read? The null states that the true mean is equal to 19.2. Exactly. And the true mean age of college students are what we're testing. What if we test Vanderbilt IQs and RIQs? We're going to test Vanderbilt IQs and RIQs. We're testing Vanderbilt IQs and we're testing UT student IQs. What does this read right here? I'm sorry, Vandy, but we beat you. So I mean, we're gonna test this now. What would this read? We'll just read as the thing. The null states that the true mean of what, because what we're testing is what to the true mean of what. Just read as a sentence. Remember, mu is true mean. Basically. But make sure you do the full thing. You're on the right track, Jacob, right there. That's what we're looking at right there. Like, that's what we're trying to see if there's evidence of. We don't know that that's the case. We're just seeing if there's evidence. So as a full sentence, try to do in your great work right there, good practice. These are the 3 nulls that we've kind of seen so far. It's 3 out of 4 of the ones we're learning for this class. So if you know these and practice these and see the different versions and know them, you're pretty good. So this would read, the null states that the true mean IQ of UT students is equal to the true mean of Vandy, which means we have the same IQs. The alternative that we're looking for evidence for is that the true mean IQ of UT students is greater than the true mean of Vandy students, which means we have, like you stated right there, Jacob. That's a more like easier way of saying it. It means that there's evidence to suggest that we have higher IQs on average. So the on average is good. And so you want to say on average. It doesn't mean we have all higher IQs than Vandy. It means on average. So, you know, it's whoever you want to test. So sorry, Vandy, a little poking fun. A little, I don't know, maybe we would fail to reject the null. Who knows what would happen when we run that test. We got to run it. Got to go do it. Okay. So next, use this value right here so we know what the null would be. To believe that your company believes the true proportion of what you consider a success of the population. Oops, wrong button. Let me click this. Clearly explain to the reader the point of the test you're performing, why it's important to your company. So 0.5 is half. So you're testing right here, you know, is it half the proportion? Like whatever you're testing, people who have diabetes, do half of them have diabetes? People who donate, do half of them donate? Whatever you're testing. And why is this important? That's going to be up to you. I can't give you the context for that. It's going to be you and your company. So just explain to them. Give a sentence or two. Why do we care about this? Without using statistical notation, explain the null and the alternative of a does not equal hypothesis test. So we just did that a second ago. Don't use statistical notation like I just did, but make sure to walk someone through what it means. Finally, using the confidence interval, write the conclusion. I want us to look at this. We can actually run some really quick statistical tests right here. This is what I like. We're going to pull it up. Who here is a fan of Taco Bell? Type yes if you are a fan of Taco Bell and type no if you're not a fan of Taco Bell. Yes if you're a fan of Taco Bell and no if you're not. We got 1 out of 1. No, we got huge yes. 4 out of 5. 4 out of 5. So I'm a 5 out of 6. 6 out of 7. What is the sample proportion of people in this sample right here? 6 people said yes, including myself, out of 7. What's the sample proportion of people who like Taco Bell? What is the sample proportion of people who like Taco Bell? What is the sample proportion of people who like Taco Bell? Include Brian in your sample. We actually would fail the, this is, confidence interval is ill created right now because we fail one of the conditions. I mean, was it random? Sure. Are we less than 10%? Sure. Last condition, you can tell we fail. What was the sample portion? I think Jacob's got it right there. It's going to be 6 out of 7. And there it is right there because 6 people said they like Taco Bell out of 7. And there it is. William's got in the chat also. Now watch this. Prop, test, and then X. Do you see X, N? And then we got P equals something right there. And is it mad at me? What's it mad? Oh, it's saying warning message. Uh-oh. That's because of the success failure condition. But look at this right here. Here's the confidence interval. Created a little bit differently than ours. But at this point, I want you to think about this. Is it believable that 50% of people like Taco Bell? Is it believable that 50% of people like Taco Bell? Why or why not? This is R, yep. We were able to run the test just like that by putting in the data, just like X is equal to 6, N is equal to 7. And I can do it over there and jump in a second too. But were we able to, yes, and Abigail said it perfectly. Abigail points in the chat. Abigail said yes because it's in the interval. And now look at this. Notice the p-value here for the test, and I think even says the does not alternative test, should say the does, there it is not equal to the alternative hypothesis, and even just says it in words for you. The alternative hypothesis is that the true proportion of people who like Taco Bell is not equal to 0.5. And the p-value is what right now currently? High or low? I'm going to redo it so you can see it a little bit better. The p-value is currently high or low right there. The p-value is currently high or low. High means above 0.05, low means lower than 0.05. If it's exactly 0.05, it's technically high, like 0.05 or higher is high. So the p-value is high, so just let the null fly. So we still believe that the true proportion is equal to 0.5, excuse me. And think about this, it's in the interval. Anything in the interval would be a value you would what? Reject or not reject. Anything in the interval would be a value you would reject or not reject. So something in the interval, is that a believable value? Not reject. Or a not believable value? Reject. You would not reject because it's something you're saying, I think it's between this and this. Like, I think the truth is somewhere here. So yeah, 50% could be true. It's a likely value. So think about this. 80% is closer to our estimate. 80% will have a higher or lower p-value. So for the project, 50% is above our interval, we would reject it. Correct. If 50% is contained outside, is not in the interval, reject it. Exactly. So since if I'm testing 80%, is 80% more believable with what we saw or less believable? Is 80% a more believable value or less believable value? More believable value, which means the p-value would be wetter for 80%. The p-value, when I rerun this test with p, don't do p equals 80%, but using p equals 80%, the true proportion is equal to 80%, the p-value is going to be wetter because it's a more believable value. So if it's more believable, the p-value telling us the probability of seeing what we saw given 80% is the truth, the p-value is going to be, you got it, you're seeing it, it's going to be higher. And here's the p-value right here. Oh, it's a p-value of 1. It's super duper likely. So what we saw right here is extremely likely given 80% is true. How about if I believe that 10% of people like Taco Bell? If I go out and even speak to, and you got to watch out because these warnings are saying maybe you shouldn't be doing this. Like the warnings like your test isn't really properly mathematically correct because of small, it's the success failure condition, but a different way of doing it. So success failure condition problem. Like if I increase the sample size here, it'll stop getting mad at me. There we go, stop getting mad. This p-value is now super duper what? It's crazy what? Very low. So this is a very low p-value. You might actually get to see this one. Oh, it's even lower, but it didn't quite reach it. It's because the same, oh, there we go. There's the p-value. That's not the, wait, no, there's the p-value. I looked at the wrong one, sorry. Yeah, there's the p-value. Does that make sense? Are you seeing how this works? That if you believe 10% of people like Taco Bell, and you were to speak to 7 people and 6 of them like Taco Bell, you'd be like, I think I'm wrong about that, right? You'd start to be like, because your belief currently is this, the way this reads is, my null hypothesis is that 10% of people like Taco Bell. I went out and spoke to 7 people and 6 of them like Taco Bell. And at this point, that's enough evidence, although the test has issues with the conditions. At this point, this would be enough evidence for you to reject and be like, yeah, I think it's more than 10, or like, I don't think it's 10%. You could actually do right here, alternative equals to, it's greater, I think you put right here. And there it is, there's the greater than test, and you still have evidence for your alternative. So at this point, you would have evidence. And all this can be run in Jump, so I'll just show really quickly how to do it in Jump. I just like that I can change that code so easily and the data inside of it. That's what I like about using R for a quick showcase of what we can do. So the same thing could have been done right here inside of Jump. If we go right here and say Taco Bell, and then we go here and say 6, 1, and then we got to say this will be count. That's count. And then we go here to Taco Bell. Taco Bell's one word, is it? Yes, no, analyze, distribution, and count. This is a little different than your data because you don't have to use the count. This is count data right here. And then we go here. And then we go to confidence interval, and we go to 95%. And it is doing the chi-squared right here, if you notice. But also 50% is contained in this interval for the yes. 50% is contained, it's just barely. And if we test right here 50%, which you don't have to do this, it should have a p-value above 0.05. Just barely with the Pearson, just barely with the Pearson. I was afraid because it's at the edge of it. So if you look at this interval right here, here's the review. Are you ready? Does this interval contain 0.05? Right here, this interval, I'll even go more zoomed in on it. Does that interval right there contain 0.05 for yes, people liking Taco Bell? Like, I am 95% confident the true proportion of people who like Taco Bell is contained in the interval 48.6% to 97.4%. My alternative is, or if I'm testing this, I believe currently that 50% of people like Taco Bell. And you don't have to do this test right here, but notice how I did the hypothesized proportion of people who like Taco Bell is equal to 50%. And so that was my null. That's my hypothesized value. And this is the test we generally use right here. And I want you to notice, do we reject 50% or not reject? This p-value, not that the likelihood test, which is slightly different. This p-value right here, do we reject or not reject? Reject or not reject with that p-value? Not reject. And is it like super duper not reject or just barely not reject? Is it super duper not reject or just barely not reject? We fail to reject, we do not reject, and is it like we just barely don't reject? And think about that because 0.5 is just barely in that interval. So if 0.5 was outside the interval, we would just barely reject if it was just barely outside. So the more centered your interval is around that value, the wider your p-value will be. The more centered your interval is around that value. Let's say it contains it, but it's more centered on it, like I'm the value. So if the interval is more centered on it, and so the value's at the middle of your interval right here, it's a more believable value because it's like in the middle of your interval. But if it's towards the edge of your interval, like if I'm the value and here's your interval, if it's in it, my nose is the value, then you would just barely not reject. And if it's outside, you just barely reject. And then the further away you go, the lower the p-value. Does that make more sense how tests are connected to intervals? And I do want to point out one last thing because this has been a really good review of a topic that we are going to talk about today in class. Let me show you this right here. When you do a hypothesis test, the way you shade it, like if you shade this side, or if you do this, is dictated by the what of the what. The way you shade, is dictated by the what of, I'm like, read Jacob's question. So what is it saying is that, and oh my God, the heart gets in the way of this. The way you shade, you either reject or don't reject the null. So we don't, the sign of the alternative, great job, William, right there. So, so what is it saying that 6 out of 7, so we saw that 6 out of 7 people like Taco Bell. And the p-value is saying that 50% is a believable value, what we saw, just to review what the output says right here. And do realize we do have issues with, so it did a fixed way of doing it, and see it's saying like no computed using score confidence intervals. So it's using certain methods which might compensate for the problems we have with the small sample size. That's what it's saying down there. And so here's the results of that, and we'll mention the last part here. Is that we are 95% confident the true proportion of people who like Taco Bell is contained in the interval 48.68% to 97.4%. 50% when tested is a value we would not reject. So the p-value here means we do not reject it. So all we're saying in short is it's possible 50% of people like Taco Bell. Like that's a believable value. The interval contains it, which means it's a believable value, and testing it, which is just a redundant method at this point, is led to not rejecting the null. So the p-value right here means that we would not reject this. We don't really say, pass is not a word really used much. We just say we don't reject it, or people will say fail to reject. I like reject and don't reject because those are complements of each other. So you'll hear me a lot of times say don't reject, but statisticians will say fail to reject. Don't say the accept word though, because that means something different than what we say. Some people will say that, but that's... What exactly do you need to include in the conclusion of the hypothesis test for the project? For this one right here, you should just be able to say, using the interval to do the test, the interval contained the value, which means I would have a p-value of above 0.05, thus not rejecting it, or the interval does not contain it. But do realize this. Here's the thing. So I'm going to point this out, because this is, since you're not using a 95. So Abigail, really good question, Abigail, right there. If you make a 98% confidence interval, what is left over in the tails then? If you make a 98% confidence interval, what is left over in the tails? 98% confidence interval, what is left over in the tails? 2%. So the does not equals alternative will have the same result as a confidence interval with 1 minus alpha. Alpha is when you reject the null. Alpha is rejection point, not an A. So when do we usually reject the null? When the p-value is what? So alpha is just a bar that you say below this I reject the null. So what is your usual alpha? What is the usual alpha? 0.05. So alpha is just a value that you reject the null at. So unless otherwise stated, we use alpha 0.05. So here's the thing. Tell me what confidence interval you made, and I'm going to tell you how it relates to yours. Tell me the confidence interval you made, and then I'm going to tell you exactly basically what to write. So we might see a lot of, so graders, if you're seeing this, this might be a lot of people writing very similar things if I say exactly what to write right here. So thank you for watching this long in the video if you did, but tell me your confidence interval, and then I'm going to tell you how to find the related alpha. So now that would mean, so think about this, if you made a 97.5% confidence interval, that means the related alpha for the two-tailed test. The two-tailed test is what? What is your relative alpha for the two-tailed test above? Like, you would get the same results using what alpha level, basically, write it. So that would mean right here. So there is the relative alpha level, meaning that if it's inside your 97.5% confidence interval, you would not reject it at the 0.025 alpha level on the does not equals test. Notice how confidence intervals are related to does not equals test directly. Does that make sense? And great job right there, Jacob. So, so Abigail, you'd write something like, since it's contained in my 97.5% confidence interval, I would not reject it on the two-tailed does not equals test at the 0.025 alpha level. Does that make sense? Because the alpha level is relative because it's going to be the outside, because the outside is the two-tailed test. So once again, I'd say that this is the not reject version if it's in your interval. So let's say here's your hypothesized value, and P naught is equal, or P is equal to 0.50, and that's in your interval. So you would say, I do not reject the value of 0.5 because it's contained inside my 97.5% confidence interval. This is relative to a two-tailed test done with a 0.025 alpha. The p-value would have to be higher than 0.025 for this test. Does that make sense? Because you not reject, so p-value has to be higher than relative alpha level. If your value is contained outside the interval, so the other instance you could be in is it's outside the interval, and so this would be the hypothesized value of 0.5 is contained outside my 97.5% confidence interval. This means I can reject it at the 0.025 alpha level. The p-value for this would be less than 0.025 because it's not a believable value because it's contained outside the interval. So good stuff right there and really good questions. So this has been an in-depth deep dive, and I hope you understand that the two-tailed does not equals test can be directly related to a confidence interval. Just think about, like, inside is the confidence interval and outside is the two-tailed test. So really good questions. This has been, I mean, we basically did the whole problem right here, and we've got the visualization thing for the others. But really good review of testing proportions, confidence intervals for proportions, and kind of the language we use. Let's do another deep dive on the project. We could do regression again, because we haven't done regression in a while. What do people want to do? Let me go get the Google Forms. I might use we did this, I don't have the start early bonus up right now. What should we do? It's your choice. The start early bonus fails the linearity condition, but the start early bonus, my gosh, it's pretty crazy. What should we do? It's your choice. 105 responses right here on view and sheet. Nothing personal on this. I had to clean up this data. Should we do regression? What should we do? You pick it, we do it. Great work on the project, everyone. Optional data right here. Let me go look. How many hours did you say? I asked this on Discord, just one good example of the executive. Oh yeah, so the executive summary, sorry for the late reply on that. The executive summary is going to have three things. Let's talk about executive summary real quick again and kind of briefly go over that. And then Cameron's, we still getting, yes, did I not put them in? I need to make sure I put them in for everything. We should be getting them. So let's talk about executive summaries and future researches. Okay. Got 201 project executive summary. Okay. So when it comes to the executive summary, let's pretend we are working for UT Sports. So if we are working for UT Sports, what would we start out saying? Like, we're working for Vol Athletics, which I don't think any of the projects really could. So I'm picking something completely different. So I have been commissioned by the UT Athletics program to analyze statistics related to player performance. The report will go over key aspects of our 2023-2024 football season and try to determine what can lead us to greater successes. So, does this make sense right here? This is just one thing about who's the report for, what's it going to be doing. That's just like, that just says it right there. This is, I've been commissioned by the UT Athletics program to do this. This is what this report's going to go over. This is not the executive summary in full. The first thing you want to do in your executive summary is what? What is the first goal of an executive summary? Anyone state the first goal as my hair just goes crazy? What is the first goal of the executive summary? First goal, goal number one is what? What is goal number one? Goal number one right here, and what is it? What is goal number one? Goal number one. Tell me goal number one as I start doing goal number two. I think states the context and how it relates to the corporation. Exactly. And I'm just making up things right here. Go Vols. Great. I think it was a good season. Not our best season ever, but hey, I think it was a pretty good season. We had some cool wins. We had some good games. Good season, Vols. I'm happy. Good win over Vandy. Good win. So we can always do better. That's what we'll say. Until we're winning every game, we can always do better. And then it gets boring. So the next thing you need to do is what? So you need to first state who it's for and the point of the project, like what you're doing this for, who it's for. And then the next thing, and a lot of people forget this, the next thing is to start to do what? Which a lot of people really make errors here. They don't do this, which I always look for. Summarize key findings, not fundings. Summarize key findings, and you must give what? You must give what? You must give what? I'll start doing the next portion right here. Summarize key findings right there. So give the numeric backing. Give the numeric backing. Those are all percentages. You can put in whatever you want from your report. You have to do this afterwards, so you can't do it right now. Give the numeric backing. Don't forget to do that, because I want my graders to always take all points if you don't give the numbers and give the specifics right there. So now, I don't want it to interfere with their life, but like, have you ever seen where like people carry a ball around and they like never let go of it? I think I've heard some football players do things like that. Like they'll carry it around for like a week and be like, I am not letting go of this. And then when they because it like creates this like thing in your head where like if you're in a game and someone like the ball starts to go, you're like, ah! You just like you do that. You probably as a football player do that instinctually, but it like even more so creates this like I do not let go of this ever. And you would hand it back to the referee and you're like, ugh! So shout out to football players. I mean, I couldn't do what they do, but I've heard of some players doing that. I don't want to interfere with their life, but we're gonna do that suggestion right there. Make it fun. You know, they can do it if they want. It's optional. An optional contest. Optional, totally optional. It's just if they want to do it, they can, and they can quit at any time. But we'll see who can do it the longest. And then if it starts to get ridiculous, where someone has like holding it, won't do it, like we'll never let go of it. We'll be like, okay, you win, you win. Stop, stop, stop. We don't want anything to interfere. All right, we're not literally doing this. Yeah, sure. I think they already do. They already do stuff like this, I'm sure. I'm sure they're looking at their 40 meters and whatever. But I'm just giving suggestions. You don't, remember, this is not a real report that you're writing, so you don't have to, you should make it relative to the data. As everyone knows right here, why did I suggest they walk around with a ball? Why did I suggest we make them faster? Why did I suggest these things? I want you to think about why my suggestions are the way they are at for part 3, which is the suggestions. Why are my suggestions the way they are? Like, why did I come up with these suggestions, which are just made up? Go Vols, good season. But why did I come up with these suggestions right here? Why did I come up with those suggestions? They're based off of, exactly, they're based off of number 2, exactly. So, you know, this is the part that we need to think about, like, what are our suggestions related to the data? And this right here looks like, it's big text, but I mean, you want your executive summary to look about half-ish of a page. That's probably a good executive summary. So maybe if I decrease the text size a little bit, it's not gonna be a half page, but pretty good. This is, think about, you've already done all the research. Shouldn't be too hard to write this on who's the report for, what did you find out, and you know, make sure you kind of give an overview of what your report is. And think about this. This is my whole report, basically. It has who's the report for, what did we find out, with the numeric backing. You shouldn't, let me double check what Terry put, because I'm hard. Let me double check. We've had that issues where people put it in the future research. Future research kind of goes into new ideas. So here's the rubric right here. Executive summary, there it is right there. Action item right here. Boom. There's the action item. The executive summary gives a clear action item, and action item is something for the company to pursue based on the results, right there. Part number 1, the executive summary should orient the reader to who the company is and what they are researching. Action item, part number 2, the executive summary gives a summary of important details found throughout the report. And look at this, must use numeric backing, must use numeric backing. Does that make sense right there? So we have the 3 things. It's clear who the, from the start, who the project's for and what is being analyzed. We should have that in our report. I should get full marks on that. A summary of the results found throughout the project is given. The goal is shrink what is in the report into a paragraph that communicates important findings. Must use numeric backing. So the data sets for the project, depending on which variables you choose to choose to use. How do you suggest we give key findings? Whatever you find. Don't worry, just, you know, we're pretty lenient. You don't have to come up with the most amazing things in the world. Whatever you find and whatever you think, you can just make sure it's connected to the data though. Whatever you're suggesting, you don't have to give the most, we're not gonna be like, that was a great suggestion. It just has to be connected to the data. So your suggestions need, you can't just be like, my suggestion is get more data. And you gotta write that at any time. So you wanna make sure it's connected to the data. Like you're making an action item decision based on data that you have. See that right there, action item is clear and also connected to the report. So do you think I would get all marks? I think I would get all marks from the grader if I wrote this for a report. Because I have a clear start on who's it for and what's being studied. I've given a summary of my project. I might add a little more. They might say, it was too short. I would talk to my teacher if they said it was too short. I'd be like, it's not that long a report. It's a 3-page report, and I put it to a half page. And then last but not least, connected right there. Last, so we'll talk about the future research right here. Future research. So let's mark this in here, future research. One project the future research. Future research is new ideas that go, and what does this say? New ideas that do what? Now, it does say at the end, future research is clear and also connected to the report. Can't say, yeah, we're going to do donuts right here. We're going to make donuts as a team. We're going to go into a donut business. Watch my video on making donuts yesterday. So when you go beyond the report, you would have something for future research. Like a future research for mine would be, please do not write exactly what I write. I guess you have a warning, don't. Because the way I phrase things, I don't want to see every report saying this right here. Does that make sense? Please don't write. Let me write this right here. Like, please don't write what I write. Please don't do that. It could kind of half saying don't do this because you are then copying me if you write exactly what I write. So please don't write what I write right here. It's kind of like more like trying to not get you in trouble. It's just, yeah, come up with your own ideas. You got it. You can do it. A key aspect of figuring out how to win football games is awesome analytics. The only way to get this will be with better measuring equipment on players. We can buy a contract with analytics amazing are us for $50 million. And they will give us the best ever. Although this is pricey, I have come up with a strategy for getting donations from all fans around the world. I believe, and I'll do 5 million. 50 million is insane. They lowered their price. I believe the better analytics will lead to better decisions, better playing, and probably better pizza. There you go. Don't put that at the end. So does that make sense? So how does this look right here? This is kind of what a future research is, coming up with things, it really came down to the analytics of the team. So I've got my future research. Please don't copy exactly what I write. Don't be like a key aspect of figuring out how to do this. Don't write a key aspect. I don't want to see everyone's thing say a key aspect. It's just whatever you think. We're only going to grade you on, did you come up with new ideas? The whole report's been connected to the team winning games, collecting data on football players, whatever you think could or should be done with this that goes beyond your current report. I don't have this data. We haven't done this contract, so I don't have this, but hopefully this all makes sense. The 3 parts right here, and there's only one thing to grade on the future research, is that you go beyond the report and you come up with new ideas that are somehow connected to the report. You don't just say like I said, start a donut business. Someone's gonna write that now. It's funny. I'm just seeing it over the years. I'll say like, don't do this or write this or don't write this, and people write it. So I'm like, no. So that's the future research. Any other questions? Good to see Lakin and Michael, Jacob and everyone, Abigail. Any other questions? I think people project's not too bad, right? You just do the data, you analyze the data. I think it's not that bad. I hope people aren't like worst project ever, really hard to do. I hope people are like, not that bad. Oh, thank you. Someone just hit the heart button right there. So what happens if I hit it? That's where it's so interesting. It just sends them in the chat and then you can just hit the button. It's such a, they added that in I know, right? They added it in a little while ago and you can do the 100 or something like that. And it's pretty interesting. Yeah. Yeah, I know, right? Anyways, what other questions do we have? Should we do the regression or something? Should we do regression? I think people know how to do regression pretty well, but whatever you want. There's a few other aspects to the project we didn't talk about today, but we kind of did last week too. Make sure to look at the rubric. Yeah, sure, let's do regression. Make sure to look at the rubric for the grading because the graders are going to go by this. So if you should get all your points if you go by the rubric. Go by the rubric and you double check things and you're like, did I do this? Did I do this? Did I do this? Get your points. Okay, so the only thing we really wouldn't have done today is the one sample T, which is not that bad. So regression right here. Let me put the timestamp in the video. Call to 7:13, step 201, project regression. Select another quantitative variable, so you need to use your first one that you may suspect a linear relationship with the first quantitative variable. So you have two quantitative variables at this point because the condition for regression is what in the chat for 10,000 points. Drop the first condition for regression. Something, straight enough. Know this. Plot doesn't thicken. Blank. I say I can't do it. QQ, straight enough. No outliers. Plot doesn't thicken, meaning two quantitative variables. Create a scatter plot, which is two quantitative variables visualization. Identify the strength, direction, form, and unusual features. Why didn't we identify the strength? Strength, direction, form, unusual features. Oh, how about the strength here? Probably with the R-squared, excuse me. Looking for my mouse, there it is. Clearly note any outliers that may exist in the scatter plot. Okay, so I'll start doing this right here. Okay, so first off, I guess I'll do it with the data as it's not cleaned up. This is an analysis we did of people studying and their grades. It's all anonymized, and this was completely optional. So optional survey right here. People didn't even have to be honest, but optional survey right here. Analyze, fit y by x. Remember, we're going to use our first quantitative variable. Maybe it was grades I wanted to analyze. And the second quantitative variable is, does how much you study explain your grade? You do the chapter 15 quiz problems, finds test statistics and p-values. Yeah, which one? Drew dropped the full thing in. We might have just enough time right after this to do it. Or I'll find you the video, Drew. Thank you, Drew, right there. Tell me which problem it is, like the start of it. I'll take a look here and do it in a moment. So what was your grade? How many hours did you study? So does your studying explain why you get a certain grade? You see I read right there? Does studying explain why you get a certain grade? And so first off, I mean, I can analyze it this way, but there's going to be a very big what. So we go up here and we go to the red arrow and we go to fit line. And you already see the issue with this regression. The big issue with this regression is one extreme and one pretty large what? One extreme, well, it's pulling in the direction. The outliers, there's outliers here. Probably due to high influence, something we don't talk about right here in our class. Can I not get the influence plots on these? Where's influence plots? Really? No influence plots? Really? Oh, you have to do the residuals, I think. Let's save residuals. Plot residuals, which you should probably go to plot residuals. And where's an influence plot? You can show me an influence plot? Give me an influence plot. That is a large residual, and this one is probably due to the impact it's having on it. Large residual also. I mean, it's not that larger. Pulling the model in a direction. Yeah, this is a bad regression right here because the extreme points are having too much pull on it. That point is a bit of an outlier. I mean, you've got outlier down there, outlier there, outlier there. And yeah, this one, the national, yeah, I might have just enough time for that. Oh, the yogurt one. Oh. And so I would say there is also maybe a linearity issue because if you look, the line doesn't go through the data, but there's also a lack of data. I'm going to remove these points just because I don't think someone studied 100 hours for the test. If you did, it's a lot. And I'm going to redo this regression. So let me go to hide and exclude. Do not do this on yours. I don't think the project calls for it. This data just looks so weird and messy. I don't like it. Now this looks better. Okay. Now this is where I would say we have a minor outlier. Does everyone see here? We have a minor outlier. Does everyone notice this minor outlier right here? Because something far away from the model, the further it is away, the more of an outlier it is. Do you also see this cone shape starting to form? That might be an issue with what? It actually looks really linear now. What's interesting is the more you study, the lower your grade. But it starts to look, it's linear, and there's a cone shape, which is going to be easier to see down here, I think. This is the one we look at. Plot thickening, exactly. I'd say we have minor plot thickening. Notice how it's a little thinner here, a little thicker, There's that outlier we talked about. So I would say there's minor plot thickening because it's a little thicker down here. That's where it's a little thicker, and it's a little thinner in there. So we're talking about the vertical spread of it. Once again, and it flips it in jump. I never liked that jump does that. This is a little thinner. Look at the vertical spread, and then over here at the end, it has more vertical spread. So a little plot thickening, minor outlier. Overall, I would say this isn't that bad. The linearity is good. It does have 2 quantitative variables, but it's overall a pretty decent regression to the conditions. R squared is only 5.4% of the variation in test grade is explained by hours studied. Let's look at the sheet here again. Oh. And evaluate the 4th condition with the residual plot. It looked kind of, hey, Emma, good to see you here. In your write-up, include the 4 conditions. QQ, straight enough, no outliers, plot doesn't thicken. And what I probably would do is I'd list them out for the grader the following way. Oh my God. I do. Two quantitative variables. I wouldn't say QQ. Oh my gosh, I can't type. Fair enough. No outliers. There we go. So right there, QQ straight enough, 2 quantitative variables straight enough. You can say linearity condition, no outliers, and plot doesn't thicken, which is the 4th condition. There's no real order to them. We just check them in that order a lot of times because we like to. And you write up, interpret the 4 conditions, regardless if your conditions are passed or failed. Provide the interpretation of the slope, the intercept, and the R squared. So once again, please check out my visualization videos on these. It's pinned in the chat right there. But can anyone do, and we'll do the last problem here, can anyone do the interpretation, also evaluate statistically significant? Can you interpret my intercept, my slope, my R squared for this? The values are here on the screen. You can see the value of the intercept right here. You can also kind of confirm it by looking over here at the model. You can see that's about 81.45. You can see the slope right here, which is very interesting because it's negative. So we should think about how this would read and what it would mean. Can anyone do any of these right here? This was your test 2. When you say for each 1 unit increase in X, we expect Y to increase or decrease by V1 on average. That's the slope. And check out the visualization video where I go over this step by step and give you it on the screen for you to see. Also, the intercept would be when X is equal to 0, we expect Y to equal B0 on average, or you can throw an on average on the slope too. So for each 1 unit increase in X, we expect Y to increase by B1 on average. Please check out the video if I'm talking too quickly. Check out the video. We got a little bit of time. I want to do that last question. Last, the R squared is blank percent of the variation Y is explained by the variation in X. So all of these would read 5.4% of the variation. When study hours is equal to 0, we predict that the test grade will be an 81.45 on average. You can throw a little on average there on 2. I think the grade should give full credit. Great job, Jacob, right there. For each additional hour someone studies, we predict that their test grade will decrease by 0.88 on average. And so I think we did all of them. 5.4% of the variation. Someone's test grade is explained by how long they study. Last but not least, the statistical significance is the significance of the slope, which is this value right here. The variable was study, and the slope has a p-value of 0.0179, which means there is a statistically significant relationship to studying and your grade, but the relationship is negative, indicating people who study more are expected to make lower grades. But that doesn't mean studying decreases your grades. It's just an association, which means there could be lurking variables. Like people who don't study have already studied by coming to class or something. Does that make sense? Like, this doesn't mean studying causes you to fail, but it does show people who study more generally do worse on the Stat 201 test. So someone's like, I shouldn't study for test 3. Like, no! This is not a controlled experiment where it's some people study and some people not study. There's so many lurking variables of like, do you come to class? Do you do the work? Do you do the My Pearson work? My guess is people who do all that study less because they're more prepared. My guess is that there's lurking variables, but that's just a hypothesis. I don't have the data to back it yet. Okay, so please study. Moral of the story, please study for test 3. I still believe in studying. The negative coefficients probably due to lurking variables. We'd have to, I wish I had the data on everything. Like, if I could connect that to my Pearson, but it's anonymous, I could then look at your grades and see like 2 people who are otherwise identical where one studies more than the other, how does it impact their grades? And then I could control for other lurking variables. In multiple regression, like when you have multiple x's, you just put the other x's in the model and they control for the other variables. And really easy to do. Once you know how to do it though, kind of how to do it. Quiz question, the National Center for Education on yogurt statistics. So let's see, we start class in 20 minutes, but I think we should have enough time right here to do it. So pull this up over here. We got a yogurt question. 11 brands of yogurt. 11 brands of yogurt. Potato chips. 11 brands of yogurt, and we got the data in JUMP. So we're going to kind of speed runish this question. I've got this question elsewhere. I can find you the longer version where I go over it more slowly. Are you still here, Drew? We will do this question. And it says this is Stat 201, Chapter 15. This is 11 yogurts. Yogurt brand. Okay. So since this data is already given to us as numeric values, we're going to copy it and put it inside of JUMP. Go here to the little arrow and click the copy button and copy to clipboard. Now hit Command-C or Control-C. Going over to JUMP now, we're going to click inside of a data sheet, and then we're going to click Control-N or File, New, Data Table. Control-N works too. Now make sure to do Control-V and notice how there's nothing in the column head. You can do Edit Paste, but do not paste with column names because there's no column name. Now that you're here, go to Analyze, Distribution. Analyze, Distribution. Under Analyze Distribution, you've already got the Y column clicked, so double click it and click OK. Now, stack it to make it look pretty. You can do anything you want else, like adding a count axis, but we're not turning this in, but just makes it look more pretty. So now we have our data. We can see what the histogram looks like. It's a small data set. Slight bimodality, slight left skew. Mean is lower than median, or that's the median. A little right skew. It's a small data set. Not too much can be gleaned on the structure of it yet, but let's go ahead and analyze the data here. So they want us to run a hypothesis test on this. The conditions are random, randomly selected yogurt brands. 10% less, 11 yogurts is less than 10% of all yogurts. So we got probably a lot of yogurts. And last but not least, the data needs to be nearly normal. Yes, that is correct, nearly normal. So we're probably good. Independence, did they select random yogurts? I think they did, right? Sure, we'll assume it has been. Nearly normal is plausible because it looks kind of normal. It's kind of normal, it's not heavily skewed. Therefore, the student t-model for instances should be reliable, should be good. We are testing that the average is 120, so mu equals 120 is the null. Make sure to know it before you click it. So we're testing if it is that. The alternative should be it's not that. So mu equals 120. And we should be testing it's not that because they're seeing if it is this or if it's not this. Now the test statistic we would calculate by hand a lot of times. But the great thing about JUMP is when you run this, you can just go here to test mean and go to the red arrow. So let me show you again where to click. Go to the second red arrow and go to test mean. When you go to test mean, you can just go in here and type the hypothesized value of 120, and it'll go here and already run the hypothesis test for you. So there's the hypothesis test, and the p-values go in the following order. The p-value first off, move it here to the right so I can point at it. Oh my gosh, there we go. The p-value is the does not equals first. That's the absolute value of t, greater than. The greater than test, the greater than is greater than is greater than. And then the less than is that. So you have your less than test, your greater than test, and your does not equals, depending on which alternative you use. We wanted the does not equals, so the p-value of 0.2383 and the test statistic of 1.25. 2383. I don't know if it rounded. State your conclusion. Oh my gosh, what did I do right there? There we go. I put in, don't do that. P-values can only be between 0 and 1. I looked at that and I was like, what did I do? State your conclusion. Well, the p-value is above 0.05, so we fail to reject the null. We do not reject. Ooh, good wording, my Pearson. That means there is not evidence, and that we do not have sufficient evidence that is different from this, and we should be good here. Check those answers. 90%. What does it mean about we do not reject? Did I get a decimal place wrong? 2 decimals, 3 decimals. Let me look at my decimals. 0.283. There we go. 0.238. And t statistic of 1.25. Hypothesized value is the alternative. Are we trying to show it's greater than? No, we're not doing that. No, we are doing this right here. The independence condition Oh, has been violated. Really? Okay. I misread it saying it has been violated. No, we have no evidence of being violated. Actually, we should just ask, are these random yogurts? I wish they just said we got random yogurts. So that, sorry about that. Like, what did I do? So it's saying has not been violated. I thought it was has been met, has not been met. But usually because they do that, they're just changing the wording on me. So with that, good work. Sorry about that. Sometimes we get a little bit wrong, but randomness, random, 10%, and nearly normal should be good on all the conditions. With that, we can run the test. We came back not rejecting the null, which means 120 is a believable value. So last but not least, that means 120 will be in the interval. Take a look at your 95% confidence interval. So the 95% confidence interval has 120 contained in it, as in we would not reject 120. With that, start class here in a little bit. Bye for now, everyone. Bye.